I recognize not everyone was finished, but it looked like some people were finished and some people were not. You know, the nature of this is I wanted to, hopefully find that right balance. Don't know if I did or not. Let's actually go through this. So now we have two different physics techniques to come up with the equations, three different math techniques that I showed in class, but there's also more math techniques besides what I showed in class. So I'm just going to do sort of a hodgepodge of methods here. I'm going to do the one current per wire, even though most of you did mesh analysis. So when I'm doing one current per wire, I have a junction here, I have a junction here. So my currents are running between the junctions. So I picked I1, and just looking at the nature of the battery here, this is trying to force current that way, that's trying to force current that way. So it kind of looks like I1 is going to be going like that. I2, I suspect, would be going down, especially if you think about, I've got these two sort of pumping the current like that, and this is pumping it this way, so it makes sense that it would go down. And then I3, I've got this pushing, these two pushing that way, this one's pushing the opposite way. I suspect I3 is going to go this, like that. And if I'm wrong, then I'll get a negative sign. My voltage loop is, I pick a spot, and it's completely independent of how I've drawn my currents. So again, I like my first one to be positive, so I'm going to go this and go that way. Start there and go that way. So I have 2 minus 4I1 minus 3I2 plus 4 minus 2I1 equals 0. So that is the left loop. Any questions how I came up with that equation? And it could be as simple as, how'd you get that equation? It's looking like there's a certain level of comfort there. I have a choice of either the whole thing or the right loop, and it really doesn't matter which one I pick. I'm just going to do a right loop because that's what I usually do, and there it is. I'm going to start here this time, and I'm going to go this way. So I get 4 plus 3 minus 1I3 minus 3I2 equals 0. Now between this and the mesh analysis, the one current per loop, I find this a little bit simpler for me just because I'm not dealing with two different currents in the middle and having to go with, all right, so I'm going with the current here, I'm going against the current there. To me, it requires a little less thinking. The math's a little bit more complicated because I have 3 unknowns, but the setting up of the equations to me just seems a little bit more natural. And the third equation is the junction rule. And so I have I1 and I3 going into the top junction, and I have I2 coming out. Now, if I just do straight substitution into these two equations with this, then I'm in essence deriving the mesh analysis equations. Mesh analysis basically skips that step. I'm going to simplify what I have here. So I have 6 minus 6I1 minus 3I2 equals 0. 7 minus 1I1 minus 1I3 minus 3I2 equals 0. And then I1 minus I2 plus I3 equals 0. Just a quick check, make sure I didn't screw up my minus sign somewhere.
No question up, Fox.
Yes, Jabez.
If we decided to do the whole loop, like if we did the left loop and the whole loop,
Yep.
would it be different from this, or would we still have the junction rule? And
No, you still have the junction. If you're doing the one current per wire, you'd still have the junction rule. If you did I misunderstand the question?
So I don't know if I did this wrong, but I only had 2 equations, which I probably should have 3. Should I have 3?
How many unknowns did you have?
2.
So you just did the physics technique I did today, where we just did the 2 loops,
Yes.
yeah, then you have only 2.
Okay.
That's the second one.
That's fine.
Yeah, the first physics technique to come up with the equations, you would use the junction also. But if you're doing the, just the loop, the wires, 1 current per loop, like I did earlier today, then junction rule's already built in. Other questions right now? Depends on how we want to do this. Matter of fact, since I'm gonna mix methods here, I'm just gonna do substitution. I'm gonna take this right here and plop it in for I2, here and here. So I have 6 minus 6I1 minus 3I1 plus I3 equals 0. 7 minus I3, 1I3, minus 3 times I1 plus I3 equals 0. So this becomes 6 minus 9I1 minus 3I3 equals 0. And then 7 minus 3I1 minus 4I3 equals 0. And potentially, if you did the mesh analysis, you would have ended up with some 2 equations that look similar to that. Then let's shoot over for Cramer's rule. So 9I1 minus 3I3 equals 6. 3I1 plus 4, oops, that should be a plus there, plus 4I3 equals 7. I1 is going to be equal to 9, 3, 3, 4, and then 6, 7, 3, 4. So it's 24 minus 21 over 36 minus 9, which is 3/27, which is 1/9. And so now I'm just going to plug into this equation right here. So I have 9 times 1/9 plus 3I3 equals 6. That's equal to 1. So I have 3I3 equal to 5. I3 is equal to 5/3. And I know I1 plus I3 equals I2. So I2 is just the sum of those 2 things, which is 16/3. No, yes, 16/9. They're all positive, which means that I correctly guess which way the currents will be going. Sometimes it's not as obvious, and sometimes I just don't feel like thinking through that and just automatically just go, let's just make I1 and I3 always go towards the middle and I2 always go down. When I'm grading it, I have a spreadsheet that that's universal. I think I have all the batteries always going up so that I put in a negative number if it's going down. And I have the currents always going, I think I have all the currents always going up in my spreadsheet. So also an example of how you can sort of mix and match the math techniques. And then the double-edged sword of checking your work. I have 3 answers here. I can then plug them back into one of these 2 equations right here just to see if I get that works out. And if not, then it's a decision to make of, well, probably just a small little error, and so it'd be a minor deduction, or did you just completely mess it up? And depends on how much time you have and how much time you're willing to commit. It's also, occasionally I'll do it so that all the answers are integers, which again is a double-edged sword, because if you don't get an integer, now you're stuck with this. I know it's supposed to be an integer, but. And I think on that note, have a lovely weekend. Your test is on Wednesday.
I know.